is OSDC. One small thing in the beginning. If you have any questions during the presentation or after the presentation, please raise your hand and I will hand you the microphone. I will try to hand you the microphone so that you can all hear you. And now, Jan-Piet Mens with Ansible. Enjoy.
And if you have questions during the presentation, please go ahead. It doesn't bother me. Good morning. Jan-Piet Mens is my name. I'd like to tell you a little bit about Ansible, the new or relatively new configuration management system. First, technical question. Can you all hear me properly? Yeah? Good. My name is Jan-Piet, or JP. I'm a consultant, an architect. I'm a bit of an author. I play around with all sorts of software. I'm an independent consultant. And one of the things that I got to know is Ansible. Now, once upon a time, we had shell scripts and SSH loops and things, and then it got complicated. By complicated, I mean we got stuff like Puppet, Chef, bconfig, cfengine. Do anybody here uses Puppet, Chef, bconfig, cfengine? Raise your hands. Okay, about half. I'm not here to convert you. If you have a running system and you're pleased with it, for goodness sakes, don't touch it. I mean, really don't touch it. Ansible is positioned, particularly in my opinion anyway, particularly for those of us who don't have anything and who want to start with configuration management. So what do we want? We want to keep things simple. We would like something that looks a little bit like this. Here's the terminal session, which I've kept as small as possible so that you could read something. I hope you can read something. I have a file called hosts, and that's a file that contains our machines. And I add a host to that, and then I run what is called an Ansible playbook to install and configure a small package. This is, of course, trivial, but as I say, I wanted to have it fit there. And we see Ansible starts off, checks all the individual hosts. Those that are green have nothing to do, and those that are yellow, something has changed. So the first task is install tmux package. That was changed on that new host Kanga. Second task is configure tmux. That was changed on the host Kanga. Those two tasks are over, and we have a recap of the whole play, and we have our, 2, 4, 6 hosts, one with 2 changes, the rest, everything okay, no change, no hosts unreachable, nothing failed, etc. So, extremely simple to run. What we want, or what we don't want any more daemons. We don't want agents on the nodes that we want to manage. We don't want yet another PKI. We don't want yet another host that we have to manage. We don't want another management host. We don't want yet more ports open in our firewall for communication required for configuration management. We don't want databases. In other words, automation must be kept as simple as possible. Okay, it must be easy and ought to not require programming experience. Now here comes, of course, a lousy pun, but I had to. It is compréhensible. The French word compréhensible means understandable or verständlich in German. Careful, this is misspelled. So, welcome to Ansible. Ansible is by default, a push-based system, although pull-based is possible, and I'll show you how to do that. Ansible can literally, and this has been proven time and time again, literally take you from zero, from having absolutely nothing, to production in minutes. Ansible has the following requirements. Python 2.5 on the management system. The management system is either a dedicated machine that you have for running Ansible. It doesn't have to be dedicated. Many people use, for example, their own workstations. I beg your pardon, Python 2.6 plus these modules, Paramiko, which is an SSH implementation in Python, PyYAML, Jinja 2, which is the templating system. These modules must be installed on the manager, on the system from which you're going to manage your nodes. Python 2.4 is required on the nodes that you are going to manage. And the sole requirement there is the simple JSON package, because or module, because Ansible communicates up and down between nodes with JSON. Ansible does not have to be installed. You can run it directly from a Git checkout. Many people do, so do I. You can run it in a virtual environment. Python virtual env, I suppose you or assume you know that. So it doesn't have to be installed. Python can, though, be installed. There are RPM packages, step packages, etc., for almost any flavor of Linux or that you run. Ansible uses secure shell to communicate between the manager system and the nodes that we are going to manage, under the assumption that we already have SSH anyway for managing this infrastructure. So that is the reason why we don't need additional ports open. We don't need additional communication protocols. Everything happens over SSH. And Ansible supports whatever SSH supports. So private keys, Kerberos, and if you absolutely must, then passwords. Ansible does not need to log on to the remote node as root. It can log on as any user. So for example, if you are in the area of development and it's your task to deploy a particular application onto a bunch of hosts, and you can do that without using root, then Ansible is what you need. It can log in as any user and copy files and transport files, change configuration files, etc. If you do have to, for example, install system packages, then you can use sudo. Ansible can automatically use sudo. At the bottom right is a picture of a cake. Now, this is a very painful cake because this was a real cake a few weeks ago, 5-6 weeks ago. I had that cake baked as a small apology to a client because on a Friday afternoon I deployed onto 400+ machines a sudoers file out of a template that had a trailing comma on a line. Do you know what happens then? Sudo considers that a syntax error. And if sudo considers that the file has a syntax error, it won't run. So within just 2 minutes, I literally killed sudo on a quite large number of boxes. So as a small apology, I had that cake made. And so that's real. Okay, how does Ansible work? Ansible, on the left, we have our, what I'm calling here the management node, that it can be, as I say, a dedicated machine. It could be a laptop, whatever. And that has an inventory file called hosts, and a bunch of modules, and so-called playbooks. We'll look at all this individually in a moment. Ansible then connects via SSH. SSH is one possible connection mechanism, but connects via SSH in parallel to a number of nodes, copies modules over, launches those, does whatever it has to do, and gets feedback of what happened. So on the nodes, we need no daemons. We don't need a special PKI. Everything happens over SSH, no ports, no databases, etc. Ansible is good in doing things ad hoc. I know people who, for example, have a Puppet installation, but are interested in using Ansible because Puppet is not able to, at least to my knowledge, is not able to, you can't with Puppet say, I would right now like to copy this file onto 27 of my hosts. You have to create recipes for that. Ansible can do that very nicely, so ad hoc operations. Ansible can, of course, also install packages with yum and apt or apt, zipper if you must, etc. Ansible has a minimal configuration language, so no big XML, no Ruby, no nothing. It's what is called a YAML file, yet another markup language, which is just a simple enumeration of statements. So let's look a little bit at the Ansible inventory file. The inventory file, by default, is called /etc Ansible hosts, is an ini type file which contains groups. Here we have, can you see my little red dot there? Okay, here we have a group called local, and a group called web servers, and a group called dev servers. And here in this group web servers, for example, I have a host called www.example.com. And I have, what is this now here, 13 web servers, web 10, 11, 12, etc. And I have a machine called Sushi. Now, this machine called Sushi is not resolvable via the DNS or via my local /etc/hosts. So I specify with a particular variable, Ansible SSH host, that it is actually running on 127.0.0.1 and Ansible SSH port 222. This, for example, could be a vagrant box, something running locally for you. We see here another example of setting variable. Here on this, for this host, www.example.com, I'm setting a variable called ntp to this value, ntp1.pool.org. What happens with that variable, we can't see now yet. We might or may not be using it later on. But we can set on a per host level, we can set variables which we can then subsequently use in our configuration. This hosts file is typically a text file, but it can also be an executable. Ansible can detect or detects whether the program is, beg your pardon, whether that file host is executable, and if it is, it will launch it. First of all, to get a list of all your inventory, and second of all, to get details on a particular host. So, creating an executable hosts file would allow us to, for example, extract information, inventory information from maybe an existing configuration management database, LDAP, SQL, etc. It would allow us to get information, for example, from Cobbler. There actually is a plugin already available to get for Ansible to obtain information from Cobbler. There are modules to obtain information from EC2 or OpenStack, or you can very, very easily create your own. It's could be a shell script, could be a Python program, could be an executable C program, Perl script, whatever you like, which emits JSON to inform Ansible which hosts and what variables we have. When we run Ansible, we have to specify a target. Which hosts are we going to target? We can target a particular group, here for example web servers. We can target the group all hosts in our inventory. We can target, for example, a group but not Web 20. Or you can specify wildcards. Okay, so the specification of the targets that Ansible is going to actually connect to can be done relatively with relatively great flexibility. Here's an example of running the Ansible command to do an ad hoc copy. I suddenly realized that we have to copy a new resolver configuration file to our development servers. Please recall, keeping it easy, I'm just going back twice here. Please recall that dev service here in this case contains just a single host, okay? But it's irrelevant. So Ansible, where's my dot there? Ansible target -m module. We'll see Ansible does work with modules. And here I'm invoking the copy module, and the copy module will copy a file. And each module can have one or more arguments, and these are specified as a single string in -a. So source is this file, and destination is that file. Ansible now connects to these hosts in parallel in groups of 5, connects over there, copies the module over, copies over the file that we're actually going to transport, in other words, this resolve.conf file. The module does its thing being, in this case, checking whether it can actually copy the file, checking whether the target file has the same hash, MD5 hash, as the source file, in which case nothing has to be done. Most modules, not all, but most modules in Ansible are idempotent. You can run them n times, and it will only change something once. Does whatever it has to do, and returns information of what it actually has done. This output here, which looks like JSON, actually it's a JSON object. This output we typically won't see when we're running a playbook. A playbook is a group of Ansible modules that we're going to invoke. But if we want to, we can actually see that. And so this is truncated a little bit, but we see, for example, argument changed has been set to true. So in other words, we know that that file actually has been copied. The target file has been changed. And we see the permissions and the ownership and so on. And here you see the source file this is now the source file on the remote node. It's actually a temporary file that Ansible created. So upon invoking the copy module, Ansible copied over our source file into a temporary file and is using that now on the target node to actually perform the copy. Ansible typically obtains facts from the nodes it connects to. And this is just a very, very short excerpt, for space reasons, on the type of information. The facts that are returned are all more or less self-explanatory. So you have system architecture, you have the whole network configuration, interface addresses, IPv4 and v6, obviously, if the host is v6 capable. The Linux or operating system distribution, the fully qualified domain name, the host name, which is the short name, etc. How much swap is there? Here we see, for example, it's a KVM host. So these facts are obtained, and we can use these facts to organize our configuration. If the target nodes have OHI and factor installed, then you can use those in addition. Then facts from OHI and factor would be returned, and a prefix then with OHI underscore, respectively, with factor underscore. On the other hand, it is to be assumed that if you're using Ansible, it's because you don't want to use Puppet or Chef, so you will probably then not have OHI or factor. There's not terribly much in those that is not returned by the Ansible facts. I spoke already about modules. Ansible does its work with modules. So it's the task of an individual module to actually do something. At last count, I took this list day before yesterday, I think. At last count, there were currently almost 80 modules, so-called core modules. Ansible core modules are those that are distributed together with Ansible. So if you do a git pull, if you do a git checkout, then you would get all these modules. There's a whole bunch of additional modules, of course, that people create for particular reasons, for their own purposes, which they're willing to share with you, but they're not considered by the project to be valuable enough to be integrated in core. So this is a list of all the modules, and I've highlighted a few here. For example, apt or yum for package installation, or also de-installation. Assemble is a rather nice module. It can take a directory containing fragments and assemble them all into a file. Or there's command module, for example. You can run a command. You can say, Friday afternoon, I've quit, I've resigned. Ansible all -m command shutdown. Your whole data center goes down. Yeah? The command or shell, which is the shell module, where the command is run through a shell on the target node, are of course not necessarily idempotent. It's one of the, I think, two of the only exceptions. Then there's the copy module we've seen, cron, which allows you to create cron entries, cron tab entries, EC2 for managing Amazon EC2 instances. Fetch, quite interesting. You are asked, what is the current content of file XYZ on all my machines? Good question. Ansible, all -m, fetch, source file, destination file. And then Ansible goes on and fetches these files and drops them into a tree indexed by a fully qualified hostname. And you can then work on that locally. Get URL, I, for example, wrote, which allows you from a node to obtain the content of an HTTP or FTP URL. Then there's mail for sending mail, for example, to alert other administrators that something has happened or that your deployment was successful. There's template, which I'll show you in a moment, which allows us to template out a file. So there's quite a large number of volumes. RabbitMQ, you want to manage PostgreSQL databases or MySQL databases, it's there. RabbitMQ, the user module, very nice, which allows you to create user and group, which allows you to create new users, remove users, add SSH public keys, etc., etc., etc. Very nice, quite new module is URI, which allows us to perform REST requests. So, for example, you can actually, with Ansible, manage stuff, equipment that doesn't have Python or it doesn't have SSH. If it has a REST API, you can, with the URI module, manage that, send off REST requests to it. Right. Sorry. Playbooks. Playbooks are YAML. YAML stands for yet another markup language. And playbooks are used for operating system configuration, application deployment, and are basically collections of actions which are executed in order using modules. The modules, just go back for a second, the modules that we just spoke about. Each group of actions is a play, and a playbook can contain more than one play. I will show you in a moment why you would like to do that. So let me show you shortly the playbooks that are used way at the beginning in that screenshot, as we saw, to install and configure tmux. So this is YAML, usually or typically identified by the 3 dashes, a single line containing 3 dashes. And here we have a list of a host that we want to target, the target user, whether we should do sudo yes or no. Here I'm specifying variables, talk about these in a moment, and then we have a number of tasks, and each task typically has a name and an action. Name and an action, name and an action. The name is optional, but you should specify it. It can help people who are running your playbook for the first time to understand what's actually happening. It's a little bit like a comment, but that comment is printed out to standard out when you invoke the playbook. These variables I can set in a number of places. We'll talk about it here. I'm defining a variable called edit mode, which is set to the characters VI. So what do we have here? We have an action called yum, that is a module, with a package name and the state that I would like it to have it in. So this will connect to my dev servers and install, if necessary, the package called tmux. Then we have an action template. Source file is tmux.conf.j2, destination file is /etc/tmux.conf. And then we have another action, which is a shell echo Ansible fully qualified domain name into a file called /temp/list. And this is delegated to another host. I'll discuss that in a moment with you. So that's what the playbook looks like that we used before. Variables we can define in a number of locations. Let me just go back. Here at the top, for example, in a playbook, we saw already we can configure variables in the inventory file. We can have so-called host variable files, or group variable files, to configure variables on a per host or per group of host basis, or from the register keyword. The register allows us to use, for example, a shell module or command module to execute a program on the target node, collect its standard output, and copy that into a particular variable, which we then want to subsequently use in our playbook. These files, these host var files or group var files, are defined as YAML. So these are YAML files. Here is one with edit mode, administrator name, location, etc. Just an enumeration of individual variables. Any questions so far? Okay. Templates. Templates are used in Ansible with the Jinja 2 templating engine, which must be installed on the management node. And templates allow us to do constructions as follows. Here on the top is the source that I'm using, and here on the bottom is what it expands to. Okay, so this is what I'm editing, and this is what will be created on the target node. So let me just go back and show you where we are. We're here, we're running a template on the source file, and the destination file will be created on the target nodes. Okay. So here, for example, we have a special variable, special Jinja 2 variable in double braces called Ansible managed. This will translate to Ansible managed source file name modified on UTC timestamp by user on host. So it's quite nice. Somebody looks at that file on the target node sometime later and see, oh, that's tracked by Ansible. We have to go back to the original. Well, we have to go back to the source file. Jinja 2 supports comments, for example. This line doesn't show up here at all. And then we have just text which is copied over, or certain variables that are inserted. This variable edit mode was the variable that I'd configured in the playbook. Jinja 2, the templating engine, allows quite a bit more. And I'll just give you an example which is unrelated to what we're doing. It has nothing to do with tmux, just an example to show you that it can go quite a bit deeper. Here, Ansible has a host vars variable, and this host vars variable contains information, all the facts about the hosts that I'm contacting during a particular run. And if I iterate through these and grab out the IPv4 address, the host name, and the fully qualified host name, what I actually do is create what looks like a /etc/hosts file. Okay, you might want to look at that quietly sometime later. Ansible supports lookup functions. There are lookup functions for doing all sorts of things. We can look up text from plain files. We can obtain text from a pipe. And this text, the result of a lookup function, can be used, for example, in a template or in a playbook to branch off and do different things. There's a lookup function for Redis, which I made. There's a lookup function to obtain values from DNS text records, etc. It's relatively easy to create lookup functions. Yeah. I've mentioned already the word delegation. What we can do in Ansible is to delegate a particular action to a host. And what actually happens during that moment is, from our management node, Ansible will normally connect to our nodes and do particular tasks, all the tasks in our playbook. And we had one example. Please delegate this to an external node. And what Ansible then does is it sort of hops or jumps over to that node to perform a particular action. This is useful, for example, in orchestration. You have 100 web servers, and you want to start updating them. And you want to instruct your load balancer, or you want to instruct your Nagios or Isinga system, please, I know that things are going to break now, it's going to go offline, so take them out. Tell Isinga or Nagios, stop monitoring these hosts. So at the beginning of a playbook, we could delegate out, tell our monitoring system with the Nagios plugin, disable alerting for this host, do whatever we have to do, and at the end, bring back alerting for that host. Okay, so we delegate particular tasks out, take hosts out of a load balancer chain, etc., things like that. That's quite powerful, quite interesting. While Ansible is typically used in push mode, we can also use Ansible in a pull mode. In this case, this is nothing really Ansible specific. What the way this basically works is we have a repository containing our playbooks, our configuration, etc. This repository is pushed out or pulled in by the nodes, Git repository, SVN, subversion, whatever. So the nodes obtain the content of the repository and then run Ansible locally on themselves. Many people like that. There are people who don't like pull mode because things happen while they can't see it. Some people prefer to watch what's actually happening. Pull mode, Ansible in pull mode has one severe, to my opinion, one severe disadvantage. It requires, since it's a full Ansible running on each node, it requires a full installation. It requires all the dependencies, Paramiko, PyYAML, Jinja 2, etc., installed on each and every one of the nodes. But there are people who are managing several hundred, even a few thousand hosts with Ansible in pull mode. So it can be done. This microphone is slipping. Can you still hear me? Yeah. Due to the fact that Ansible uses SSH to connect to hosts, it's not blindingly fast. Ansible has to initiate an SSH connection to each node, copy its stuff over, do whatever it has to do, and then disconnect. This can already be very greatly improved upon if you use OpenSSH with what is called control master function. Anybody know control master? Control master has been around since OpenSSH a long time, and allows OpenSSH to create a connection, and all subsequent connections will be multiplexed over that. You don't have to touch the SSH servers on the nodes. You just need control master support on the client. In other words, on your management laptop, let's say. So that's already quite an improvement. If you want it really, really fast, then go to what is called fireball mode. In fireball mode, I mentioned initially that Ansible supports different connection types. Fireball mode is, in addition to SSH connection type, which we've been discussing all the time now, is a 0MQ connection. And what happens is we will, and I'll show you a playbook with which you can do that in a moment, we will, from our management node, connect to the nodes via SSH and say, start fireball mode, and the rest of the communication will then happen over 0MQ, which is really pretty fast. The disadvantage is that one of the great things of Ansible, in my opinion at least, is the fact that I don't need any software on the nodes to be able to manage them. That advantage disappears when we use fireball mode because we need on the nodes, we need 0MQ and 1 or 2 Python modules for which to do that. But if you have first of all, you could install those via Ansible. And second of all, if you have a very large infrastructure, many, many thousands of hosts, you might actually be very pleased with fireball mode because it really speeds things up quite dramatically. So here's an example playbook with 2 plays. I mentioned a playbook can contain 2 plays. Here's our first play. There's the host word, and here's our second play. I am targeting a group of hosts called name servers via connection SSH, and I have a single task with an action fireball. So Ansible will connect to these machines via SSH and will, as root, as sudo, launch fireball mode. And what it does is it launches an ephemeral process, a short-lived process, which will automatically die after configurable. I think it's 10 or 15 minutes. And that process sets up the 0MQ socket business and creates keys with which Fireball will authenticate to the nodes. It then disconnects, and that process is kept running for a few minutes. And then Ansible comes around with the next connection type, Fireball, and then here, task, 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 copy, copy, template, whatever. And then really just fires this off, shoots this off via Fireball mode, via the 0MQ socket to the target machines. So it's really quite an impressive difference, but, as I say, requires additional software on the nodes, which many people don't like to have to do. Ansible is fully embeddable. Ansible comes with an API which we can leverage into our own programs. And here's a trivial example of a Python program. Ansible is written in Python, of course, of a Python program. I have an import, Ansible runner, and I then launch Ansible runner on a host pattern. This pattern specifies the machines that I want to connect to. And I specify a module name and module arguments, similar to our Ansible command line. So here's the command module, and it's going to run user bin uptime and run. This minuscule program of mine will now leverage the Ansible infrastructure, will connect, as usual, via SSH to these nodes, will copy over the command module, will run the uptime program, and will collect its result and bring it back as a JSON data structure. And somewhere here we have, there we go, standard out. And here we have our uptime of 100 days and so and so much load average, etc. If this program had created JSON, we would see that structured here, but this is just normal standard out, standard error, which is returned to us, and we can then continue using that in our program. So we can embed Ansible quite easily. Ansible is extensible via so-called callbacks, which must be written in Python, via action plugins or data sources, which are typically also written in Python, via modules, as we've seen already, which can be written in any language. Python, I beg your pardon, modules need not be written in Python. There are a couple of modules in Shell or Bash script. You can write modules in Perl if you prefer. You can write modules in Ruby and linked C programs, whatever you like. There's only one requirement. This module must be executable on the target node because Ansible copies the module over. So if on your laptop you are a Ruby developer or a Ruby administrator and you want to create a module in Ruby, that's fine. But please remember that during execution, Ansible will copy this module over, so all requirements that are necessary for your module must exist on the target node. Okay? And inventory sources, as we saw the host enumeration, inventory sources which can be specified or can be created in any language you want, because they are run exclusively on the management system. Management system sounds so highfalutin. As I say, it could be a laptop. And it actually often is a laptop. I recently, at a customer, deployed quite a large number of DNS servers. I was sitting at home, and I did that without touching their infrastructure with Ansible from my workstation. So the only thing I had to do was ask them to please create a specific user and place an SSH public key in whatever home directory it was, and that's it. So I was able to deploy, for people like myself, it's absolutely brilliant, because I was able to deploy stuff onto their site without modifying the infrastructure. I didn't have to install agents. I didn't have to ask them to run this command, such and such command. So that is really what I personally consider extremely attractive of Ansible. You can use it without touching the remote node. Don't need any daemons or agents or whatever. So in other words, more stuff for time that matters, for people who have all sorts of other jobs to do. And I would strongly recommend you have a look at Ansible. It's a maturing project. It's been around for just over a year. Current version is 1.1, 1.2 should be coming out in a couple months. My recommendation is to run directly from a Git checkout, because then you have, you always have the newest features. It's very easy to contribute to the project. Quite a number of contributors. It's 1,000 followers, I think, on GitHub. Ansible was created by a man called Michael DeHaan. That name might or may not sound familiar to you. He's the man who created Cobbler, and he's one of the people behind Funk. So somebody who's been around the block a little bit, and Ansible is good fun. Any questions? Yes, hang on a second. You're welcome to ask in whatever your language you like. I mean, German is French, Spanish, English is fine.
Basically, two questions. The first one, it sounds a little bit like it's pretty similar to what Fabric does in some ways, and it's also Python, and it used to use Paramiko. Do you know any reasons why somebody kind of created some similar thing again, except for, I don't know, personal preferences?
No, on the other hand, I'm also not really qualified enough to answer your question, because I'm not familiar enough with Fabric. I know the name, but I've never worked with it, so I certainly cannot compare it. I'm frequently asked, can you compare Ansible to Salt, or Salt Stack, I think the official name is. Anybody heard of Salt Stack? Salt Stack and Ansible are similar principle. Salt Stack works on the basis of agents, so-called minions, that need to run on nodes, and they communicate via 0MQ. So, no, I'm sorry, I can't honestly answer your question because I'm not familiar enough with Salt Stack.
Because it's pretty similar in many ways.
Okay.
One of them being that you also only basically need Python, if at all, on the client or on the on the machines to be changed, and similar stuff. And the other question was regarding pseudo passwords. How do you pass them on?
You can pass pseudo passwords on from a playbook, respectively from the command line with -K, I think is the option. You can pass a pseudo password on, which of course means that each time you run Ansible, you have to pass the pseudo password along. So, which also means that if you want to automate that, for example, cron or whatever, you would need to embed your pseudo password in cron tab, which you're not going to like. Well, I hope you're not going to like doing that. My very strong recommendation, and I know that there are people who hate that, is, and that's the only way that you can have a cake like that. My very strong recommendation is for a particular user, create a particular user, perhaps called Ansible, and give that user a passwordless sudo. That is the most elegant way of doing things. There are people who say it's insecure. Might be. Each and every one of us has to define that for himself. I personally consider a passwordless sudo on a node less insecure than carrying around a clear text pseudo password.
Agreed, and thank you.
So it works with passwords. I wouldn't like to have to do it. Yeah. There were some more questions here.
Okay. Suppose you have two types of machines, maybe 20 of each in each data center. And you have a configuration file which is dependent on type of machine and data center the machine is in.
Yes.
And I want to distribute a new configuration file for each machine of type B in all data centers.
Yes.
How would I do that?
Okay, there are a number of ways. Let me go back to a playbook here, please. There are a number of... Where's my playbook? There. There are a number of ways. First of all, you can probably, what you probably will want to do is create groups. So you have a group called Data Center 1 with those machines and Data Center 2 with those machines. So first of all, you can deploy to a particular data center by specifying a group name. So Ansible Playbook, target, you can give that on the command line also, no? But target host would be Data Center 1, and then you go to all machines in that data center. You can add hosts to different groups. So you can specify that group, but not that group. So by doing that, you also split it out. There's a whole, or quite a large number of things that I haven't shown you here for time reasons, but you can also tag individual actions. You can say, you can add a line there saying tag, for example, DC1. And then you can run this playbook and specify with an option -T, I think it is, tag, please run this playbook, but only tasks that are tagged this way. So there's a large number of different ways to separate, to group things together, and there are people who do exactly what you're asking. Target all Debian systems in data center 1, or target all RHEL systems in data center number 17. That is quite easy, using groups, using tags. We can send, in Ansible 1.2, no, in Ansible 1.2, it just came out a couple of weeks ago, there will be roles. You can specify roles for particular machines, and doing so, you can create sort of miniature playbooks that are sort of virtually included into bigger playbooks. So that is possible.
Yeah, my problem, which we have with other my problem, which we have with other management and distribution tools too, is I don't want to maintain, for example, 500 config files, always the same for 500 machines.
Oh no, of course not.
Yeah,
that would be horror.
But how would I address a configuration file for exactly such a group? Because I have two groups, and I would have a matching rule. Would need to have a matching rule which combines these two rules to match one file.
Okay.
So
Now I understood your question. Thank you. Template is your friend. Okay. Template is your friend. You have, I mean, let me repeat in case somebody didn't hear that. Managing 500 different versions of a configuration file for 500 machines, that is horror, okay? We don't do that. That's forbidden. Template is your friend. Here's a trivial example. I mean, this is an example because I don't have it here, but this configuration here goes to category A machine, and this configuration with a different variable, for example, or with a different set of lines goes to category 2. And here again is Jinja 2 syntax. No? Here you see we have loops. We also have if. We can check for equality. We can, in a template, we can say if target DC, that's the name of my variable or name of your variable, if target DC is DC1, then add these lines, else add those lines. Okay? So that is, I would call it almost trivial. I do that, for example, I've done that at a client who has, no, you don't want to know what he has, but he has lots of machines with all sorts of different versions. I mean, you name it. There's no Slackware, but I think everything else exists. And different architecture. So I'm templating out an SSH server file, and if you sshd.conf or _conf has a path to userlib SFTP, but that is architecture dependent. So sometimes userlib and sometimes userlib64. Trivial to do in a template. Yeah. Does that answer your question?
Yep.
Good. Any other questions?
Such a question regarding the, do you have any kind of, what general this...
Could you speak into the mic? Sorry, I can't hear you.
Yes, what Ansible can do, what Puppet doesn't?
What can Ansible do that Puppet doesn't? Well, to be honest, nothing. Let me rephrase that. To be honest, there's one thing that Ansible does that Puppet certainly cannot, at least not to my knowledge, and that is this. Ad hoc operations. There are people who run large Puppet infrastructures, and for doing more or less ad hoc operations, they run a product by RIP now, M Collective. And M Collective can sort of, launch something against a lot. But for running M Collective, you also have to configure, I don't know what it's called, they have a specific term for it. You also have to write a wrapper that says, do this, and if the code is 0, then return that, else return that. Ansible is quite powerful in doing ad hoc things. You suddenly realize you want to reboot your web service. Yeah, run Ansible. Puppet cannot do that without a strenuous, more or less strenuous configuration. Okay?
You can easily do it with a PD shell.
I beg your pardon?
You can easily do it with the PD shell. I mean, usually people what are doing
but
with...
PD shell is not Puppet.
It's not Puppet, definitely, yeah, but that's yet
You
another
asked,
tool.
what can Ansible do that Puppet can't? PD shell is not Puppet. Okay? There are people who, I know Puppet consultants who, after deploying Puppet, they get the question, exactly that question from a client, how can I quickly run this and this? And then they start deploying PD shell or Funk or now even Ansible. Because Puppet doesn't offer that capability. So it's not in Puppet, okay? If you, I can only repeat what I said way at the beginning. If you have a running Puppet infrastructure, or Chef, or bconfig, or whatever they're all called, and you're satisfied with it, and you're happy with it, don't touch it, okay? Yeah, that's basically, at least as far as I can judge, that's what I would say Ansible can do that Puppet cannot by itself, and that is run ad hoc operations quickly, go grab all the files, or copy this, or reboot that, or do things, without having to write configuration.
You mentioned also that the author of this Ansible is the guy who has written the cobbler.
Yes.
Do they have any correlation between these two?
Do we have any?
Any correlation between those two software?
I'm sorry, I didn't understand you.
I mean, do they have any kind of common stage in the sense that, for instance, the forum end is using Puppet and then the dashboards and all
No, the only thing in common is that there's an inventory module for Ansible that can query cobbler, the cobbler database. But there's nothing else in common. Okay?
Will Ansible support Solaris or AIX systems with the detection of operation system type and anything like that?
Yes. AIX, I must say I'm not 100% sure. I think so. Solaris, yes, in any case. I've done it myself. That's why I can say so. There's one important thing to know, though, and that is the Ansible basically consists of two parts. It's Ansible itself, the whole managing thing, and the modules, okay? So whether a particular module works for you on AIX or on Solaris, there's no, I certainly wouldn't be able to guarantee that it does work because I might not have tested syscontrol on Solaris. It won't work because syscontrol is for Linux. And yum certainly won't work on Solaris either, okay? So basically, yes, Ansible can manage, in any case, Solaris, because I've done that. I think AIX too, but I'm not 100% sure. But of course, there might be one or two modules that don't do what you expect them to do. If you experimented with it, and if you determined, let's say, the user module, which is supposed to create a user, basically works, but this and this is broken, report it, and that would be considered a bug, because the user module must work on these platforms. So yes, it does work on Solaris.
Have you tested the shell command together with package add or package remove, for example? Not yet.
Have I done that? Oh, I'm not quite sure whether I've done that. I'm not. No, I certainly can't remember having done it. So no, but I think this is relatively new, package in, and if I'm not mistaken, I'll check in a moment. If I'm not mistaken, that is a Solaris package manager, package adder. But no, I have not.
Because it's sometimes interactive, and that this could become a problem.
Not could become it will be a problem. If you are trying to automate something, and whatever you're trying to automate suddenly becomes interactive, that is a problem. And I know because I had the great misfortune of having to do that on SLES. And SLES has the unique advantage of being a distribution that at every release they change their package management, which is really fantastic. And they have a tool called Zipper, and there's a switch called -- interactive, and you can set that to no. And in SLES 10, it became non-interactive, but in SLES something SP whatever, it became interactive again. So you were sitting there waiting for this package manager to complete, but it was running in the background waiting for standard in, waiting for TTY. So if something that you want to automate goes interactive, then we lose. Okay, that won't work. Yeah. Just a moment. Just a moment. You need a microphone.
If you have a large infrastructure with SLES in different versions, will you run Ansible in these infrastructure to install packages? Or
I can say with absolute definitivity, yes.
okay.
Because standing before you is